Hey guys, it's Mr. Nakami here. Today we're going to be continuing our lesson on 6.3, how to do a confidence level for population proportions. Right? And if you remember last time, calculating a point estimate for population proportions was real simple, right? We just took our number of successes and we just divided by the number in our sample, right? Hopefully you guys are able to see that. Right? If we survey 1,000 people and 662 said it was acceptable to do something, the p hat, the point estimate for it, was just that 662 divided by the total of number of people we questioned, which was 1,000. Right? So you need to know how to find your p hat, right? Your probability of success or proportion success, right? Because with that, we're able to find your confidence interval by adding and subtracting your margin of error. And your margin of error is, here we go. Your margin of error is very simple. It's just like in 6.1, we take the z critical score, which we would find off your normal table, but now instead of multiplying it by the standard deviation divided by the sample size, right? Now it's going to be the square root of p hat times q hat divided by n. Okay, that's the new part. Once you find out what p hat and q hat is, we're going to multiply that together and then divide that by n and then take the square root and multiply by z critical, all that stuff done on a calculator, and that will help you to find your margin of error, your E. Right? Once you do that, you just add and subtract it to your p hat, and that's it. That's your interval. Now there's a slight slight disclaimer here that you need to remember. For proportions, in order for us to use z critical, it has to be very closely approximated to the normal distribution, right? And the way we check that it is, right, is just by making sure that n times p is greater than or equal to 5 and n times q hat is greater than or equal to 5. Those two situations need to be true in order for us to use z critical. If they are not true, then we can't do this problem, right? Just like we did in the last chapter. We have to make sure that n and p and n and q are both greater than or equal to 5, right? So we're going to have to find out what p hat is and what q hat is, and then once we do that, we'll actually calculate the margin of error using your z critical, and we can find that on the table, and then just add and subtract it to your p hat. Okay, sounds like a lot, but check it out. It's actually not too bad. So we're going to be using the same problem from earlier, except now we're going to be calculating a 95% confidence interval. Okay, so just like before, or in the previous episode, p hat we found out to be was just 600 and no, p hat we found to be 0.662, right? Which means we also know what q hat is. Q hat, remember, is just 1 minus p hat, right? And that's going to be, let's do that real quick. It's just going to be, there we go, 1 minus 0.662, which is 0.338. 0.338. Now, before we actually do this problem, we need to double check, right, that n times p is greater than or equal to 5 and n times q is greater than or equal to 5. And remember, in this case, n is equal to 1,000. Okay, so we check that off on the side some more. We check that n times p is greater than or equal to 5. So 1,000 times 0.662, and that comes out to be 662. That it seems to be greater than or equal to 5. That checks out. And then we do it again for 1,000 times q of hat, which is 0.338, and that comes out to be 338. That's also greater than or equal to 5. So that checks out. We can do this. This is going to be a nice approximation of a normal distribution for us. Okay, so it checks out. We can do that. It is great. Both of them are greater than or equal to 5, so that works out. So now the next thing we need to do is find our margin of error, so we can add and subtract it to our p hat, which is right here. We're going to add and subtract that number, but we got to find out what our margin of error is first. So in order to do that, we have our p hat, we have our q hat, we have our n, we have all those things, right? And the only thing we don't have is z critical. So z critical is just like what we did in 6.1. Since we know that this is a normal distribution and we're using z critical, we need to go to our z table, right? Our normal distribution, our pink sheet, which is this guy right here. So it's telling us that it's a 95% confidence interval, right? Which is telling me that it's 95% in the middle here, which means that we're left out with just 5% on the outsides. but it's 5% split between the bottom tail and the top tail, which means that the bottom tail is 2.5%, and the top tail is also 2.5%. We only need to look up one of them though, since it's symmetric, right? And 2.5% is 0.0250. We need to find that on here. 0.250 is right there, which gives us a z critical, positive and negative, of 1.96. It's supposed to be plus or minus 1.96, right? Because the minus one is on the left side, the positive is on the right side. But of course, if you guys remember, the nice thing about the z critical is they have specific values already found for you in this little table down here, right? But it's only for specific ones like 80, 90, 95, and 99%. 95% is the most common one, and it's probably going to be the one that you use the most. So it wouldn't hurt to memorize the z critical score of 1.96, right? And that's what we're going to be using for the z critical here. So z critical is equal to 1.96, and I now have everything I need to calculate our margin of error. Our E is going to be equal to my z critical, which is 1.96, times the square root of p hat, which in this case is 0.662, times q hat, which is 0.338, divided by our n, which is 1,000. Okay? So we just plug this into a calculator. We won't bother doing all this by hand. So this is going to be 1.96. We're multiplying that with the square root of, this is going to be 0.662 times 0.338, and then this is all being divided by 1,000. And this is all still underneath the gigantic square root. Okay, we got that there. We go ahead and press enter. My margin of error comes out to be 0.0293. 0.0293. 0.0293. Technically, I only need to go to, looks like 3 decimal places, but I have, of course, a habit of going to 4. So we're just going to go to 4 decimal places there, and I think I rounded that correctly because the number after 3 is going to be a 1, right? So we got that. That's my margin of error, right? If you're doing this as a free response question, getting the margin of error is already like more than half the credit there, okay? It's a lot of work, because the last part, to do this interval, all you got to do now is just add and subtract it to your p hat, okay? So what I need to do now is write down it's p hat minus the margin of error is less than p hat plus the margin of error. Remember, this this confidence interval is to give you this interval of what you think the population proportion is going to be around, right? We don't actually know what the population proportion is, but we're doing an interval that we think that it could be around this value. Meaning if I did this 100 times, 95 of them should catch the population proportion, right? Should have it within those that interval. Okay. So anyways, we're going to just go ahead and subtract the 2 here. So it's 0.662 minus 0.0293 less than p less than 0.662 plus 0.0293. Right? We just add those 2 together, or subtract that and add that. Let's see here. Let's do the subtraction first. 0.662 minus 0.0293. That's going to give me 0.6327, 0.6327 less than p less than the same entry, but this time it's going to be a plus instead of a minus, and that gives me 0.6913. 0.6913. So what makes this different from the other section is now your answer is going to be in percentages. That's what a proportion is, right? And you're saying, no, it's a decimal. Yeah, your percentage is just less than or equal to 1, but greater than or equal to 0. You're never going to have a negative confidence interval for this, right? Because you're dealing with a proportion. So if you want to take this into context, what's the population proportion between the people who think it's okay to check their email or their personal email at work should be somewhere between 63.27% and 69.13%. Does that make sense? The proportion of the population is somewhere between 63% and 69%. That's with a 95% confidence interval. I'm confident, right, that it's going to be somewhere between 63 and 69%. I'm 95% confident, right? And that's how you construct a confidence interval for proportions, right? The other sections were all for averages, just for the mean, the average number of this, the average number of that. But now if we're trying to calculate it for a, let's say like a proportionate percentage of people who agree with this or disagree with this, or a percentage of people who have something or don't have something, we're going to be using this equation now, right? And it's pretty much the same thing as the other one. It's just now it's another equation. You still add and subtract it to your point estimate, and that gives you your upper and lower boundaries for your confidence interval. Okay. I want you guys to just try one problem for today's video. This is the only example we're doing here, and this problem right here, there's two of them. You're gonna get one of the two on Canvas. You just need to do one of them, and then just submit that for me for today's assignment. Okay, that's pretty much it for today. Hopefully you guys are doing okay. I had a couple questions of when can you do this? Is it too late to do this? You guys, with the whole situation that's going on here, just find some time to do this. I'll grade it when I can. Let me know if I've already graded it. It's been a while, and then I'll get in there and I'll grade it for you, okay? So don't worry if it's late. I'm still giving full credit for all of this. I still want you guys to just, make the best of the situation. Just still try to learn. And we're going to get through this, all right? I'll see you guys next time.